Hello everyone, my name is Vivek and my roll number is 19951821997, studying in 6th semester in Aeronautical Engineering Department in Institute of Aeronautical Engineering. Today, in the subject of finite elemental analysis, the Tech Talk topic is about what is the material for new age. So, we have had Bronze Age and Iron Age, arguably an oil and aluminum age. But what material will drive and define the world of tomorrow? So, let's see. What will be the defining material of the new industrial age be? In the past 100 years, steel gave way to oil and then silicon as information became the defining power behind industrial development. Will it return to energy with hydrogen becoming a strong contender as a replacement for petroleum, or will renewables make lithium batteries central to future development, or will other materials step in to propel industrial evolution further? Here are four contenders as the most likely candidate for the next material ages. The first one is lithium, a high energy choice. Lithium emerged as the preeminent material for electrical storage 2 decades ago. But as electrical vehicles and grid storage join the list of customers, the quantities required will grow rapidly. In less than 5 years, the demand for lithium will at least double according to several forecasters, with supply just about keeping pace thanks to the opening of new mines for the mineral spodumene. And the relentless programs of lithium seems unstoppable even though we are likely to see dramatic changes in many of the other materials that go into the batteries. In theory, silicon is better material and although it takes a lot of energy to purify, has the benefit of abundance, but it suffers from a major problem that does not afflict carbon nearly as badly. The electrodes expand when they capture lithium ions to the point where the solid state cell burns. You can avoid this by using complex chemical cocktails and non-structures, but these increase manufacturing costs. Lithium itself is not necessarily the ideal element for high density electron storage. That role has become played by cadmium, but it suffers from drawback of highly toxic nature. Another option is strontium, which is 20 times more abundant than lithium, but lithium is far lighter, a crucial consideration for products as diverse for smartphones, electric cars, and cheaper to mine. One contending problem with the lithium is it's flammable. Today's lithium oxide reduces the problems rather than avoid it completely because if high reactive pure lithium filaments form through overcharging, the oxygen present in the cell acts as an accelerant. Sulfur is a potential substitute for oxygen but suffers from the same problems as silicon electrodes. It causes the cathode to expand as it acquires lithium ions. So another factor that makes lithium status as a material for new precautions is that the competition for energy source will come from fuel cells. These can potentially offer far greater energy densities than any other can offer. The second option is the hydrogen, the lightweight option. Of all the possible materials of the future, hydrogen has the greatest potential to transform the economy. However, the problem for hydrogen is that it is only a realistic contender if it reaches a position from which it can achieve the transformation. Hydrogen's future role depends on structural change on the way energy is produced and stored. This is the main problem with hydrogen. In contrast, lithium's role will be less important if it's displayed by fuel cells in the energy infrastructure, but lithium will remain as important material for many other applications. On its own merit, hydrogen is not compelling as fuel for vehicles, but by making it part of renewable closed loop systems, it would be easier to bear the infrastructural changes and costs that result from wholesale conversion to hydrogen. One of the biggest roadblocks to energy generation based almost entirely on renewables is the requirement for energy storage. The grid needs to catch energy to ride out slumps in wind or solar production, and if nuclear generation is included in the mix. Hydrogen offers a clean alternative for storage that comes with added advantage of providing energy that can be much more mobile by weight. Hydrogen's energy density is around 140 millijoules per kg. Compared to 2 megajoules per kg for an efficient lithium-ion battery. Naturally, there is a catch with hydrogen. But the option is that it is highly porous mineral sponges such as manganese hydride developed by researchers from the University of New South Wales and Lancer University. The team claimed their system could make it feasible to store in a car the 5 kg of hydrogen needed to support a driving range of 500 kilometers. In 2015, a group of researchers from Stanford University Imperial College analyzed the cost of creating elemental hydrogen by electrolysis and storage in scenario where the energy required comes from renewables. The round trip efficiency of creating and using hydrogen was lower than that of electrochemical battery, but they calculated the lifetime cost would be lower because the efficiency to do the job would work out significantly cheaper and less environmental destructive. The third one, which is copper, the second Bronze Age. The main constituents of metal pots and elements that heralded the beginning of civilization during the Bronze Age is the copper, which is like a comeback, thanks to the way it has crept up on the other contenders from all sides. It is hard to find an energy producing or energy using product that does not use copper in some way or other, and these applications are not necessarily limited to passing electricity. Although it is 5 times less efficient than diamond, copper acts as an efficient conductor for heat. It its a much lower cost is why copper is so prevalent in high grade heat sinks for integrated circuits. Copper may even find a place in the infrastructure for delivering hydrogen. Copper as well as aluminum alloys are not only sus, uh, sus- susceptible to attack by hydrogen gas or any common materials, makes it a good choice for piping, though it runs into problems when oxygen is present. The main applicants for copper also lies at the heart of its weakness as the basis for the next material age. There simply may not be enough to go around. The big problem posed be much greater use of copper, that is, to service its demand. Miners will have to move to sites with low grade ores as shift will take place in turn to increase the energy usage, and without a change in extraction technology itself the carbon dioxide production increases, and which increases and releases more greenhouse gases, which is a threat to the environment. And the fourth one, which is the carbon. For 3 billion years, no element has a very great influence on Earth than carbon. It's not about abundant, but it's hard to think of an element that is more versatile. As a result, it became the core constituent of life on Earth. Within a billion years from its first appearance, carbon based life managed to change the composition of Earth's atmosphere. Today, it is the most efficient and the effect on its atmosphere and climate in a very different way. Carbon seems to enter into a new phase very beginning, and it has many unknown properties which are being discovered by scientists through ages, and carbon's value comes from a huge amount of variety in how it forms through these bonds, thanks to the way that electrons orbital reorganize under different conditions. The sp3 form, the sp2 form, and it forms many things like graphene, acetylene, and many structures due to this change in their configurations. Carbon uh, in the other form, which is nanoform, made of clusters of carbon atoms in a loose 3D web. This was developed by Zhu of Nanyang Technological University and Ming Wang from Southwest University. So these together they formed a 3 form in a 16 atom shell by combination of properties. So the tricky part is making these kinds of structures at low cost with a precise degree of control. So thanks to the combination of great understanding of synthetic, biological, and the structural properties of the element carbon. So with carbon we have many usage, and in future there will be many other forms coming from carbon, and it will be very beneficial to us. So welcome to the new age of carbon. Thank you.